In this lesson, we're going to be using right triangle trig in order to solve for missing sides of right triangles. Okay, so you are going to need a calculator for this, so I would grab that now if you don't have one. Here's a quick review of what we learned in previous lessons. We have our three ratios, sine, cosine, and tangent. And I put the ratios there for you. I did an example. Remember, if this is angle A, we know that the side opposite is the opposite leg. The hypotenuse is always the hypotenuse. And then this is here the adjacent leg. All right, I also put our reminder up here of SOHCAHTOA, an easy way to remember those ratios. So let's go ahead and get started. So today what we're going to do is we're going to solve for sides again. So I'm going to position myself at the angle that I know. Okay, so, and it can't be the right angle. It has to be any other angle than the right angle. So if I position myself here at the 57, the 12 is the adjacent leg. The x would be the opposite leg. Now this other side that I haven't labeled is the hypotenuse, but it's not a known value or the variable, so I don't really want to worry about it. So I got to think about which of my ratios deals with opposite and adjacent. So this is why I keep telling you SOHCAHTOA. Okay, so opposite and adjacent, that would be tangent. So we have, here's how it works. You write the tangent of the angle, so the tangent of 57 is equal to the opposite over the adjacent. So x over 12. Now, we need to solve for x. So I'm going to multiply both sides by 12. Okay, now this is pretty important here. I would make sure you always write that number in front of that constant we're multiplying by. Write it in front of the tangent of 57. The reason I say that is because, first of all, order of operations, if you type in tangent 57 into your calculator and then just put times 12 right after it, it tries to take 57 times 12 and then find a tangent of that number. You have to really remember that the tangent of 57 is a place in that table. Remember that big table I showed you? It's just referencing, it's just telling the calculator where to reference that table to figure out what that saved ratio should be. Okay, so tangent 57 is just a number. We don't want to mess up what the tangent of that value is, that angle. So in my calculator, what I'm going to do is I'm going to take 12 and then times the tangent of 57. You need to make sure your calculator is in degrees. If you have a scientific calculator, it's going to say it like in the window. Like if this is the window, a lot of times it says DEG right down here. Or maybe be on this side. Okay, if you have a graphing calculator, press the mode button, and it's about the third line down. Okay, you want to make sure degree is highlighted. If radians is highlighted, your answers are going to be all wrong. Okay, you need to be in degrees. If you are a person who likes to reset your graphing calculator a lot, it automatically defaults back to radians. Okay, so if I type in 12 times the tangent of 57, I'm going to round to just one decimal place. So we get x is equivalent to 18.5. So the length of this side is 18.5. Now, one way you can kind of check your answers a little bit as far as reasonableness. If I think back to this triangle here, I know one angle is 90, one's 57. This one would have to be 33, right? Because there's 180 degrees in every triangle. So 57 is a larger angle than 33. So that means that this side opposite the 57 should be larger than the side opposite of 33. Okay, so I can check the reasonableness of my answer. So if I would have gotten like 7 there, I should have known that I did something wrong. Okay, that's one way to tell, like if you're in radians and you get the wrong answer, or if you ever get a negative value for a side length, that probably means that you're in radians. All right, let's try another one. Okay, so we're going to situate ourselves at the 40-degree angle here. This time, let's see, we have the x here is the hypotenuse, and the 10 is the adjacent side. So our ratio that we're going to use, if you think about SOHCAHTOA, adjacent and hypotenuse, that's going to be cosine. So we have the cosine of 40 is equivalent to adjacent over hypotenuse. Now, this one is really easier to think about cross multiplication if you want to make both like into a proportion. So when I cross multiply, I get x times the cosine of 40 equals 10 times 1, or 10. I need to get x all by itself, so I'm going to divide by the cosine of 40. Now, again, cosine of 40 is just a number, right? It's a place in a table that it's pulling from its memory. The calculator is pulling from its memory. So don't type in cosine of 40 until you're ready to find your answer. So because now I have x isolated, I'm going to now type it in. So I would type in 10 divided by the cosine of 40, and I get 13.1. Okay, here's our next problem. That 20 is teeny tiny there. But this is a 20-degree angle here. Okay, and I have an adjacent and I have a hypotenuse. So that again is cosine. So we have the cosine of 20 is equivalent to adjacent over hypotenuse. So that's going to be x over 8. Okay, so to get x by itself, I just need to multiply both sides by 8. So I have x is equal to 8 times the cosine of 20. Go ahead and type that in. And I get x is equal to 7.5. All right, our next one here, we have a 49-degree angle. The 5 is the opposite side. The x is the hypotenuse. That is a sine function. So I want to use sine of my angle of 49 is equal to opposite over the hypotenuse. Okay, on this one I'm going to want to cross multiply because x is in my denominator. So I have x times the sine of 49 equals 5. I need to divide both sides by the sine of 49. So 5 divided by the sine of 49 is equal to 6.6. Okay, our next problem. This time I have a 25-degree angle here. The x is the adjacent side. The 3 is opposite. That's going to be tangent. Okay, so the tangent of 25 is equal to opposite over adjacent. So that's 3 over x. X is in my denominator, so I'm going to cross multiply. Oops. So x times the tangent of 25 is equal to 3. Divide both sides by the tangent of 25. So we have 3 divided by the tangent of 25, and I have 6.4. Okay, our last example. My 63-degree angle, the x is the adjacent, the 9 is the hypotenuse. So that's cosine. So the cosine of 63 is equal to adjacent over hypotenuse. So x over 9. Okay, and go ahead and cross multiply. I have x is equal to 9 times the cosine of 63. I'm just ready to type that right in. And I have x is equal to 4.1. And that's it.